Hello everyone. Welcome to another video on iMesh Academy YouTube channel. In this session, I will explain Flutter, its architecture and its advantage over other frameworks available in the market. I will also talk about widgets, types of widgets and how it is used in Flutter framework. Let's begin with Flutter framework. What is Flutter? Flutter is an open source mobile application SDK created by Google which support Android and iOS platforms. The first official alpha version v0.0.6, codenamed Sky, was released on May 2017. The latest official release is Flutter 1.0 and is also the stable version available at the time this code is prepared. Flutter applications are written in Dart programming language. Dart language supports hot reload, which allows developers to make changes in code while executing it on simulator, emulator, or other target devices and verify changes immediately. Flutter extends its support, which helps developers to create applications faster. One of the major components of a Flutter framework is its engine, which is written in CPP, which provides low-level runtime support using Google's Sky graphics library. Flutter engine also interfaces with platform-specific SDKs provided by Android and iOS. The engine is only a thin layer of CPP code which provides only the basic functionalities explained earlier. Flutter implements most of its system in Dart, which are available for developers and they can modify or remove based on their requirement. This gives developers tremendous control over the system as well as significantly lowers the bar to approachability for the majority of the system. Like MFC, Microsoft Foundation classes or .NET Framework class library, Flutter also has a rich set of foundation library written in Dart, which provides classes and interfaces which are used in creating applications. Developers have two ways to craft rich UI and user experience for their applications. One by using widgets and the other by using the functionalities provided by the graphics library in the foundation library. Majority of time, developers use widgets to create user interfaces for their applications. I'll explain widgets in detail later in this session. Flutter widget supports both material design, which follows Google design guidelines, and Cupertino, which follows Apple design guidelines. This enables developers to create feature-rich UI for both Android and iOS in record time. So let's try to find out the advantages of using Flutter. If you are one of those people who questions when a new framework is released and are skeptical to use it until you are convinced, well, you are not alone. I was not ready to use Flutter when it was first released in 2017. One of the main questions which I had was, why should I use Flutter? I believe this would be the confusion any experienced developer would have in mind when they heard about Flutter in the first place. I will try to answer this question in a few minutes. I have come across situations where a single application needs to be deployed in multiple platforms, mainly in iOS, Android, and Windows Phone. Before HTML5 was introduced, we did develop separate applications for all these platforms, but maintaining it was a nightmare. Things got improved after HTML5 got introduced. We could create applications which run on single source code, had better control on the project schedules and lower execution cost. But migrating to HTML5 was not an easy task. It in fact generated more bugs than a native application, but the development time was improved as we had a single source code. The Achilles heel of HTML5 was performance and compatibility across different WebKit, which caused lots of issues and workarounds were not always straightforward. We could never achieve native-like performance using HTML5 back then. As there were not many open source frameworks available, we left with what we used back then. Flutter helped us overcome all these issues. It has single source code for both Android and iOS, guarantees native performance, doesn't have any compatibility issues, as we no longer rely on WebKit, and it helped to improve the productivity a lot. Flutter, in a nutshell, provides a complete framework for your UI development. It supports React style UI, has sophisticated touch framework, provides a base set of interop libraries to interact with platform code, and has a sublinear layout. Another advantage of Flutter is that the vast online resources and sample applications provided by Google and the Flutter community. Should we try Flutter now? The choice is up to you. But hey, you're not going to lose anything. Using Flutter is very easy and it won't take much time for you to understand and start with Flutter. In this course, I will explain all the basic and advanced techniques you need to know in order to develop a Flutter application. Let's try to understand the Flutter system architecture. Flutter framework has layered architecture. Most of us need not worry about its architecture, but it is always better to understand the basics of the UI framework we are going to use. Flutter has three layers. One is embedded layer. This is the lower layer which interacts with platform and performs all the low-level code. Flutter engine. This is written using C or CPP. Graphic rendering, interop to interact with the underlying platform are some of its functionalities. The framework. Implemented using Dart language, a Flutter UI is created using the components in this framework layer. So mainly we all are interested more about the framework part because we will be using the components and the functionalities provided by this framework for all of our applications. Now that we have discussed about Flutter, let's see the building blocks of Flutter UI widgets. A widget is an immutable description of part of a user interface. Widgets describe what the UI should look like given the current configuration and state. Complex widgets can be created by using simple widgets, and Flutter has a wide range of widgets in the widget catalog. A Flutter application is created using widgets, or in other words, we build our UI out of widgets. In Flutter, every UI element is a widget. Widgets provides a configuration for the UI which will be used by the framework when it is created and rendered. Widgets have parent-child relationship. You can relate this to an XML document where a root node have multiple child nodes. Any node inside the XML document will have at most one parent node and can have multiple child nodes. Similarly, a widget can have at most one parent widget but can have any number of child widgets based on the configuration of the widgets. For example, a container widget will only have one child and a list view can have multiple children. We will learn more about this once we dive deep into code in future session. All widgets are given a unique key to identify in a widget tree. A key is identified by the framework if none is provided in its configuration. Also, widgets are immutable by design, which means all the fields declared inside the widget shall be final. Flutter supports different types of widgets. In this section, we focus on stateless widgets. Simply put, a stateless widget is a widget which doesn't change its configuration once it is created. So now we have another question. What is stateful widget? A stateful widget is a widget that describes part of the user interface by building a constellation of other widgets that describe the user interface more concretely. Stateful widgets are useful when the part of the user interface you are describing can change dynamically. An icon button or flat button can be considered for stateless widget, where the button doesn't change its configuration and description once it is created. On the other hand, a slider widget can be considered as an example for stateful widget, which changes the state and description of the widget when the slider value is changed. I believe this gives some insight into the widgets and its working and the different types of widgets in Flutter. Please subscribe and hit a thumbs up if you like the video. In the next session, we'll be explaining scaffolds and the layer system of a Flutter UI.